In this lecture, we're going to learn about range factories. And this is a facility we have in C++ to produce views out of the blue. And this is different from what we have been doing so far because we have been adapting an existing container to produce a given view on that container. For example, if we have a container of integers, we can set up a view which is only going to view even numbers from that container. But in this case, we're going to produce views out of thin air, if I can say it like that. We have a bunch of range factories in the C++ ranges library. Here I am at CPP reference. And if I scroll down a little bit, you're going to see an entry on range factories. And you see that we have one called IotaView, which is going to generate a sequence of numbers by repeatedly incrementing an initial value. And this is a much more common range factory you're going to see used a lot out there. If you want, you can try out empty view, single view, and all these other things. But I am going to try out IOTA, and this is what we're going to look at in this lecture here. So let's look at a few examples of how we can use this. We can set up an infinite view of numbers starting from 1 by setting up something like this. We're going to say std views and say iota. And this is going to generate a sequence of numbers starting from 1, and we are going to be incrementing. So we're going to get 2, 3, 4, 5, and this is going to go infinitely, as we are going to see in a minute when we hit Visual Studio Code. Now, once we do what we have on this line here, we're not going to see anything on the terminal because this is just setting up computational information and storing that in this variable called infinite view. To see the data, you have to loop through this view. And if we're trying to do that, we're going to see that this is going to loop forever because this is an unbound view or an infinite view that is going to print forever if you let it do so. We can also set this up on the fly by doing something like this, create the view in the loop on the fly. This is going to do the same thing as on top, but we can also limit the range by specifying an upper bound to our iota view. Now, if we try and do something like this, we're going to print from 1 all the way to 19 because 20 is going to be our limit. And the upper limit will not be included in our range. And we're going to see this when we hit Visual Studio Code again. We can do this in place as we do right here and generate a view in the loop. This is going to do exactly what we want. And this is going to be using a filter view that we pipe our data from iota to. So we're going to get the data from the iota view and we're going to pipe the data into a take view, which is only going to take 20 elements. And we're going to see the data from 1 all the way to 20 here. Hopefully this is making sense. It is also possible to use row function composition, and that's going to work. And this is what we are doing right here. We are taking the data from our iota view that we get right here, and we are passing this into a take view, which is only going to take 20 elements. And this is going to work exactly as we want. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Range Factories. We are going to grab the code from the template files here, and we're going to put them in place. And let's crack this open in Visual Studio Code by dragging and dropping here. This will give us our main CPP file that we can clean up as we always do. Let's remove what we don't need here. We are going to put in our includes, and what we want to play with is really range factories, and we will use iota, this view here, as a use case. Let's look at the extended documentation here. So they are going to say that this is a range factory that generates a sequence of numbers by repeatedly incrementing an initial value. And this view can be bounded up. So we can make it finite, but if it is unbounded, it is going to be infinite or unbounded here. This is something we can do, and you can even go down and look at a few examples. For example, here they have a view. They are using a view constructor here because they are using std ranges, but this is going to work anyway. So they are going to loop through the view, and the view is going to be from 1 to 9. 10 is not going to be included, and if they print the data, you're going to see 1 through 9. They can use a range adapter. You see they are using std views here. This is going to do the same thing. They can even take the initial data, which is generated by iota, and pipe that through a take view, which is only going to take 9 elements. And this is going to give us 1 through 9. This is the example we have from the official documentation. But we're going to set up our own example to show you something else you can look at. So let's go down in main and set up our code. We're going to set up an infinite view, which is going to be std views iota. This is going to start from 1. And once we do this, we will have computation information stored in this variable called infinite view. At this point, we won't see anything done on the terminal. Let's comment out the loop here to show you that we won't see anything. If we run this program as it is now, we can pass this through GCC. The build is good. We can bring out a terminal window. And if we run our program, we're not going to see anything. Let's run Rooster. You see that nothing happens. But if we loop through the view, the data is going to be generated on the fly as we go through the iterator. So once we hit the first iteration, we're going to grab the first thing from our view here. Once we hit the second iteration, we're going to grab the second thing. Once we hit the third iteration, we're going to grab the third thing. Data is going to be generated lazily on the fly as we need data in each iteration. This is what we mean here. Now, this is an infinite view. If we run the code is going to run infinitely, and our program is never going to stop unless we stop it explicitly, forcefully. Let's pass this through our compiler and show you this. The build is good. We can clear. And are you ready? Let's run Rooster, and we're going to see data printed out. And the program will keep printing indefinitely. If I wanted, I could wait for this for 15 minutes or 30 minutes or even an hour. It is going to keep going and it is not going to stop. But we can stop it by hitting Control-C on our terminal here. And this is going to kill the program because we don't want to wait for this forever. Now, one thing you can do is limit your view by specifying an upper bound. But before I do that, let's show you that we can tell it to start from 10, for example. And we're going to pass in a 10. This is going to control where your numbers are going to start from. I think this is really good to see because some people will think that it will always start from 1. That's not the case. Let's clear and run Rooster and hit Control-C. And we're going to see that our program is going to start from 10 and we're not seeing this. Let's limit this. We can specify an upper bound. Let's say we want this to go from 10 all the way to 20. So this is going to start from 10. It is going to go to all the way to 20, and 20 is not going to be included. It is an open interval, if I can say it like that. Let's pass this through the compiler and show you that. The build is good. We can clear and run Rooster, and we will see data from 10 all the way to 19. If we change our starting point to 1, let's do this. We're going to see data go from 1 all the way to 19, and this is really cool. Let's clear and run Rooster, and we're going to see data from 1 all the way to 19, and this is what we have in our output here. Now, it is also possible to specify the upper bound by just taking a given number of elements from what IOTA gives you. And we can achieve this with view composition. For example, we can compose this with a filter view, which is going to only take 10 or 20 elements. We can take however many we want. So we're going to pipe this through another view. We're going to say std views, and we're going to say take, and we're going to only take 20, for example. So this is going to take 20 elements from what we get from the IOTA view. And we're going to see that if we print this view, we're going to see 20 elements printed out. Let's pass this through the compiler. We have a squiggly line, but I don't know why. Let's see if this actually compiles. And the build is good. This must be Visual Studio Code messing with us. We can clear and run Rooster, and we're going to see that we will get data printed out from 1 all the way to 20, and this is really cool. We can also achieve the same thing by using row view composition. So let's go down and try to do that. We're going to set up another view. We're going to call this data view. You can call this whatever you want. We are going to say std views, and we're going to take, and we're going to set up a take view, which is going to take a given number of elements from our view. We're going to take 20 elements. And what do we take from? We're going to take from what we get from our IOTA view. So we're going to say std views IOTA. And IOTA is going to start from 1. And if we do this, our code is going to work. We're going to generate an infinite view, and from that view, we're going to take 20 elements. And that's what we're going to print down here. Let's change the loop to say data view, because that's what we want to loop over. And if we pass this through the compiler, let's make sure this is going to work. The build is good, so this wiggly line here is a false positive. We can clear and run Rooster, and we will see data printed out from 1 all the way to 20. This is something you can do. It is even possible to put these views directly in a loop. So for example, we can grab this entire thing and pass that in our loop, and this is going to work. If we do things that way, we have no reason to set this up as a variable in our code. We're going to generate this in the loop and use it as we loop through it, and things are going to fall in place. Let's pass this through the compiler. The build is good. We can clear and run Rooster, and we're going to get 20 elements printed out from our IOTA view because we are only taking 20 elements. We can even pass in our pipe version. Let's grab this, and we're going to replace this in. We can do something like this, and this is also going to work. We can pass this through the GCC compiler. The build is going to be good, and this is going to work. If we run our program, we're going to see 20 elements printed out. This is all I had to share in this lecture, showing you different ways you can use the IOTA view. And this is a range factory because it is going to generate numbers out of the blue. It's not going to be an adaptation of some container as we have been doing all along in this chapter. Again, we have a bunch of other range factories in the ranges library in C++20. So if you happen to need something like this, you can check them out and use them. But IOTA is far common, and you're going to see it used a lot out there, especially if you need a quick collection of numbers to work with in your C++ program. This is going to come in very handy. We are going to stop here in this lecture. In the next one, we will try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.